done his PhD and masters also. His masters is from COEP Pune. COEP Pune and Bharati Vidyapeeth.
That's UC there.
Yeah. So that is from Bangalore. And I'm very happy to introduce because we have been he has been my colleague for a very long time. We have been working as even teaching assistant from in SPNIT in 2002, 3, 4, very long ago. And sir has a lots of experience with process control specifically, PLCs, SCADAs, distributed control system. So it will be a very, very interesting session. So I hand over to G Patel.
Yeah, thank you very much. Yeah, so good afternoon all.
Good afternoon, sir.
Let us start with it. Yeah. So I'll just take one case study straight away. And actually our aim is when we turn on this pump, so I'll just tell you what is this. This is one UGT, this underground tank. This is one pump, and from pump we are having some flow. So when you turn on the pump, the maximum flow that we are achieving is 100 liter per hour. 100 liter per hour. Okay. So now suppose we want some change in this flow. Suppose we want suppose 50 liter per hour flow. Then what we can do? Just suggest some plan. What we can do? We need to control the flow. That's obvious. How we do? Very simple application we are discussing. Maybe school level, maybe we can say sometime. Using ball. Okay. So you may put some HOV. See, why I am using this short word, because in industries, if you go no, they always use the short word. Like they never use the full form. That's why purposefully I have used this short word so that we also know means how they are working with the industries. So we may go for HOV, that is head operated wall. So where you are going to put it? Maybe you can keep it over here. And here suppose you put one HOV, that is head operated wall. And maybe you can change it to 50% to get flow of 50%. That's what we'll do. Correct? And by doing it, definitely you are going to get the flow of 50 liter per hour. But question arises, is it preferred? Is it preferred? Yeah, sir is saying no.
Though it is a manual system.
Okay, it's manual system, so that's why we do not prefer, because when we do operate it, maybe it may goes to
Physically,
yeah, maybe it may go to 60, 40, 45 or 55, whatever, right? That's why maybe somebody may not trust us. Okay, fine. Sir, we don't prefer this. Why, sir?
I want to think that the motor is running at full power.
Yes. Very, very true. See, you consider both the cases. First case and second case. In both the case, power consumed by the motor is same. See, when we talk in electrical engineering, we are telling motor, but when you go mechanical, they'll tell it's pump. You understand the difference? If you go mechanical engineering, they'll tell it pump, but we tell it motor. Actually, it's a motor pump set. Alone motor can't do anything, alone pump can't do anything. It's a motor pump set. So here, power consumed by the motor is same in both the case. That's why it's a sheer wastage of energy. So that's why we do not prefer second option. Okay. So what we'll do? We need to design some system in which we need to design some control system so that we can achieve the flow as per our requirement. Correct? So that's why we made one system. Yeah, something like this. Actually, purposefully here we are going for air blower. Instead of water, we can also go for instead of water, we are going for air here purposefully because we are working in the electrical department. That's fine. So here, actually, this is an air blower system. So what is the meaning of air blower system? So we are giving solution to that problem. Which problem? This problem. How to vary the flow. Right? just to give a solution, I am proposing, or we are proposing one system. This is one system, correct? So in this system, here you take an air blower. So what is the meaning of air blower? So it will blow air into the pipe, correct? It's a, you can say it's a opposite to the exhaust fan, right? So from here air will go in this pipe. So this is the hand operated valve. And here in this system, when we turn on the pump with the full speed, it's giving us the flow of 100 kg per hour. There you take a liter because it is water, right? Here we are having air, so we are measuring the mass flow. So mass flow is like CNG, we are going for mass flow, right? CNG we are measuring in kg. So it is mass flow, it's a kg per hour. So when we turn on the pump fully, it's going to give us the flow of 100 kg per hour. Now, if you operate this hand operated valve, you can change the flow as per your requirement. But problem here is, in all cases, your motor will take the same power. Motor will take the same power. That's why we need to go for some strategy by which we can save some energy and we can also solve our problem, or we will get desired flow with minimal consume of energy. Correct? That's our aim. So for that, let us see the video first. Then we'll discuss how you have done that. Correct? Let us come on this. So any doubts so far? Any questions? So this is actually case study, so we can discuss. It's like a design problem. So if any ambiguity, any confusion, we can discuss. Basically, that coordinator has purposefully kept all the case study lectures in afternoon sessions, purposefully, so that we all can discuss and we can have proper interest in that. Okay, so actually, volume check. I will volume check, but it's like because they can hear the volume of the water running. That volume is there. Like when water speed is increasing, they can see very clearly. They can hear very clearly. So actually, this is SCADA screen. So we are controlling the entire system from the SCADA only. Correct? And let us start with it. So the SCADA screen. So normally SCADA will have an entire replica of the entire process. Whatever we are doing, that process will be there in the SCADA. And normally that is the actual system. The same motor. So this is pipe. And on pipe you can see some white cloth because actually internally, we have kept some heater also. So this equipment is made for variety of purpose. Like we can control the flow, we can control the temperature, we can control the motor speed. So when we go for the temperature control, temperature may go to say around more than 100 degrees. That's why this thermal insulation, this white cloth, is basically for thermal insulation. So this is your head operated valve. Resolution is somewhat weak here, so but this head operated valve you can see you can operate this in the range of say 0 to 90 degree, and when you do it in 0 to 90 degree, you can control the flow in the range of 0 to 100%. Maybe light, switch off one light. You can change it in the range of 0 to 100%. Correct? So afterwards we will discuss how extensively we have done. Let's see. So this is actually panel where PLC and VFD all the things are there. We'll understand about it now. Let's see the video first. This is the control transformer VFD. Okay. So this many things we can do. Like we can control the flow, we can control the speed, we can control the temperature. So first we are controlling the flow. So So this is what the SCADA we are entering, that is 100. Or so I'll just explain the meaning of set flow means water flow that we want from the system that will put as a set flow. And this is the actual flow. So this will display the lower speed, it's motor speed you can say. Then pressure in the pipe. Definitely we need to measure this pressure also, because sometimes if pressure increases it may burst also. Then we have the temperature 1 and temperature 2. Actually there we put two temperature sensors. Afterwards I'll show you. So they are measuring the temperatures. Okay. And this entire thing control we are doing by setting the gain PID gains, that is Kp, Ti, Td and Kp, Ti and Td. C means control value. So we are setting 100 kg per hour. We are making the blower on or system on, you can say. See, this entire thing we are doing on SCADA. And when see, so now surprise thing is we are just clicking on the SCADA screen with that actual 3-phase motor is getting on. Correct? And nowadays because of IoT, we can keep the SCADA anywhere in the world. It may be possible that SCADA you keep it in the USA, from USA you control the plant of Surat City, possible. Even from mobile nowadays, earlier people used to go in night shift to do some correction in the plant, but now people are doing from mobile only. That's a benefit now because of the IoT and the internet. So you just click the blower on. So now you can see 100 kg is the desired flow, this 100, right? So it keeps on varying. See, this 100, it is down at 100. So can anyone tell me where is the actual flow? Where is the variation? See, here is the variation. Set value is this. I'll give this video to you. Maybe you can see on your screen. It will be clearly visible. This is the set value, and here this is varying. So we can see that exactly 100 is not achieved. Is it achieved exactly 100?
It's varying.
It's varying. Exactly 100 is not achieved. It's varying. See. Maybe you can say variation is there. So from 2 to 5% variation is there. So will you prefer this? Obviously no. Right? See, it's varying. So why it's not coming? Because the value of TID gains what you have said is not proper. So you have to tune the controller. So that's why we are changing some of the parameter in the controller. So still it's not varying. Still it's not achieved to the desired value. It keeps on varying. So now what you have done, that video, actually what you have done, then again we have changed the parameter there and we have done the change in the set point.
Yes.
That part of video was not taken unfortunately. So in that what you have done, we have changed the set value to the 50. And we have changed the parameter there also, that KP, KD, KI parameter, that also you have set. If you need, I can explain what we have changed, I can explain that very clearly. So that you have changed, so now it's coming very close to it, see. So it's coming very, very close to it. The deviation is very, very small. And actually, exact definition, if we go for settling time, no, in control system, it's actually 2 to 5% bend. So 2% bend means once something comes within 98% to 102, it's considered to be settled. The variation is not considered at all. You see, it's almost as you see. So now we made it 0. So it's coming to 0. So once you tune your controller, then you put any set value, it will achieve in the same manner. Let us see now. So actually earlier value was 100 and tuning was not so proper, that's why it was oscillating. So now then we have changed the value to the 50 and we have also tuned the controller. So because of that, it's achieved. Then we have put the set value 0, so it's coming to 0. reaching to 0, see it's reached to 0. Now we'll change the value. Yeah. Again 50 we are putting. See, this is set value, it's going. This is actually overshoot. Then it's falling, undershoot. Again overshoot. So if you tune the control properly, then within 4 cycles it will get settled. It's any system. Suppose it's any controller or anywhere. It's in any field. If you tune the control properly, in 4 cycles it should get settled. See, 1, 2, 3, 4. It's settled.
Sir,
Yeah.
for every single change in that flow, KPK kid is different?
No.
Or it's saving some bandwidth?
No. Actually, what happened? No. This is only for the initial. Initially, it was not coming. Purposefully, you have done it actually.
Okay.
So purposefully, you done it in such a way that it got achieved. So then you done the change. So only one time change is required.
Okay.
See, if you want to know about tuning, I'll give one simple example. For example, if somebody is from this department, so when you join this department on very first day, you might have seen that states. First day, states you might be watching the states. Second day, third day onwards, without watching the states, you are climbing it. Because our mind is doing tuning. Similar way, this control also do the tuning. Once it's tuned, in that set of or that range of set point, there is no need to tuning again. It will come. That's why purposefully we have done 100 to no. Let us stop video. Purposefully, purposefully we have changed set point 100 to 50 just to end the changes and then it comes to 50. Then again we did 0. And now again from 0 we are doing 50 to just to see whether 50 is coming or not. Right? So once control is tuned, there is no need to tune it again and again and again. Once it's tuned for that range. Correct? See, now if you go to any petrol pump, they don't do tuning, right? Somebody go for 100 rupees petrol, somebody go for 1000 rupees petrol, somebody go for 5000 rupees petrol. Every time we just put a set value, and we are getting of that level of fuel. They don't do tuning every time. It's only one time tune. Over. They have some laws. They need to do calibration at frequent interval, like some years or something, as per the law. But once you design the controller, once it's tuned, it will be tuned. Deviation won't come. I think that was your question, correct? Yeah. Every time we don't need to set value of KPKD cap. Actually, purposefully you have done this for initial value. So now again, just go back. So we set 150. So what I was telling, after 4 cycles it will get set up. See, if you observe here also it's 4 cycles only. 1, 2, 3, 4. Somebody can see overshoot, undershoot very clearly. And somebody can also clear the fundamental of control system with this. See. Now suppose it's coming, see, it's coming exactly to this. Exactly to this. It's a real video, right? Actually it's coming to the desired value. And it will maintain there. It's coming to that, it will maintain there. See now, now if you close the wall fully, what will happen? See, now this system is working in closed loop. I hope, any idea about closed loop? Anyone? It's a feedback, right? So in closed loop, normally what happens? Definitely we have to discuss that after some time. In that normally what happens? Whatever value, so in closed system, you have basically input and you have basically output. So can anyone tell what is output and what is input? What is input and what is output?
Input is a reference signal.
Input is a reference signal and what is output?
Feedback signal.
Control system, design.
No, what is output?
Input.
Actually,
Output means
be anything.
Desired value of output is actually input to the system. See, for example, this is room AC we are having, correct? So in the room AC we set 26 dB over there. So what is set value? It's actually desired value of output. We want this AC to operate in such a way that it will get 26 degree of temperature. So desired value of output is basically your input to the closed loop system. To take any example, for example, here we set the flow of 50. 50 was what? Actually, it is a desired value of output. We want flow to be 50. That's why we set 50. Suppose you go to petrol pump. Suppose we go to petrol of 5,000 rupees or 2,000 rupees. Then we set 2,000. That person will set 2,000 rupees because we want petrol of 2,000 rupees. That's why. So desired value of output is basically your input to the closed loop system. Correct? And whatever control strategies are there, they are actually maintaining both only. Like whatever may be the input, it will try to make input same as that of output. Or you can say it will make output same as that of input. Both should mesh. Correct? So here, so this system is working in closed loop. That's why we are getting the desired flow. Like whatever flow we are setting, no, we were set earlier 100. So initially it was not coming, but after doing some setting, it was coming. Then we set 50, it was achieved. We set 0, it's achieved. Correct? So desired value of flow was 50. So now system is working in closed loop. That's why that is happening. Definitely I'll discuss about it little later. Once we go in much theory, we'll go for that. So ultimately, whatever we set, so system is working in closed loop. That's why this is happening. Correct? So now, and control system will put its all effort to maintain output same as that of input. It will put it all effort to maintain output same as that of input. Clear? So now, suppose I ask somebody to close the wall, head up to the wall fully closed. Correct? See, motor is running, air board is running, and you are making the wall closed. Correct? Wall closed. Say, what will happen to the? What will happen? Pressure increase. Very good. Yes, pressure increase. Okay. What happened to the motor speed?
Decrease.
Motor speed will be down. Because loading is there.
It will decrease.
Okay, sure. Fine. First, pressure will increase. Everyone agree, right? Second, number 2. What will happen to the flow? Water flow, air flow. You are closing the wall.
It's not coming out zero. Output is zero.
Yes, if you close the wall fully, your flow should become 0, right? Agree? Because it's not flowing, right? If you close the wall fully, suppose, then it won't go. Flow will be 0. Correct? Flow will be 0. Okay. What about pressure increase? What about motor speed?
Decrease.
Decrease?
No.
Motor speed increase. Okay, fine.
Motor will be loaded.
Huh? Fully loaded means?
Will decrease.
We are suddenly closing the valve so that the button will be on the back, जो back पे तो भी pressure
हाँ. And
so that will decrease the
That means it will increase the current.
By taking more current,
will be more.
motor will try to getting back to the original speed due to
original speed or rated speed?
rated speed. Before closing of that valve, whatever the condition, motor will try to achieve that suddenly by taking more current from the.
Rated speed will be decreasing.
It will be rated speed, right? See, now here what happened? Again, go back. See, your system is working in closed loop. So the intention of the control system was what? Or the purpose of the control system was what? To maintain the output same as the desired value of input. Now you change the desired value of input. Have you changed the desired value of input? No. It's a 50 only. But you make the actual value of flow 0. So there is a huge error there will be a huge error for the controller. So it will be in the action and it will try to nullify that difference. So, and how difference can be nullified?
Increasing control effort.
Yeah, so what is the meaning of increasing control effort? In this case, what should happen?
Motor will start taking more current.
Motor?
The speed will increase.
Yes, motor speed will increase. See, obviously, if you are having less flow, to increase the flow, you need to increase the motor speed only. So motor speed will increase. So how much it will increase? It will reach to the maximum speed. It down with the maximum speed. Correct? And that's why you can see here. So I have asked him to close the ball fully, but I think he has not closed it fully. Something was left. So that's why now let us see the SCADA screen. Yeah, see, here you can see this is falling, right? It's falling to almost zero. It's almost zero, but it's not actually zero. And now at that time, actually in this no, the sound is also there. You can see here the sound of motor also, like the way it's increasing, the way it's decreasing, all you can hear.
2.92.
See here you can see the motor speed. It's a 2915 RPM. It's actually maximum rated, maximum speed. This is 2-pole machine, 2-pole induction motor. So maximum speed, synchronous speed is around 3000 RPM. So rated speed is around 2920 or something RPM. So that's why motor speed is increased to a very high value. Correct? So, but by increasing speed also, will it achieve? Control will achieve the desired flow. Will it achieve the desired flow?
No.
Because the disturbance is heavy. Correct? So now suppose we reduce the disturbance, suppose we open the valve fully. Suppose we open the valve fully, then what will happen to number one motor speed?
Decrease.
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 Motor speed will decrease.
Gradual decrease because it will reach to the desired value.
Okay. What will happen to the flow? What will happen to the flow?
Flow increase.
Flow will
Try to reach its set level.
to the setting value.
Directly? Gradually.
To max.
Okay. So see now what happened? No. Already your motor is moving at a very high speed. So as soon as you open a valve, suddenly flow will increase to very high value. Flow will increase to a very high value. So now controller is in action. So flow is high, desired flow is low, so it will decrease the motor speed again. So you have increase will happen till you have desired flow. I hope this is clear, right? Because now flow is 0 and desired flow is 50. So as soon as you open it, so motor is moving at the high speed, so it will increase the flow. So it will be very high flow. It may reach to the more than 60, 70, 80, 90. So the 90 and 50 again flow is more. Desired flow is 50 and actual flow is 90. So it will decrease again. So the decrease will happen. It will keep on happen till we achieve the desired value of flow. Correct? So let us see this. See that you open the valves, you can see the stuff in the flow. And this is nothing but the transient. It's nothing but the transient. See, rarely you can see the transient for some applications. So here you can see the transient very easily. Power system transient, rarely visible. Right? Is there something? Here you can see it very easily. Right? So if somebody want to know about transient, they can see very easily. Here you can see this is a transient out here. And see, motor speed is decreasing. Again, this is having up and down. And after some time, it will achieve. See, it's achieved. Means once disturbance is over, again system is in action and it achieves the desired level of output. Correct? So now, just to achieve it, can anyone tell me what type of sensor you might have used over here? To achieve this, to take a feedback, what sensor we might have used? Flow meter, yes. Then second, So I'll give the description of all the sensors because in STP also something about control system and sensor confusion. I'll just tell you which sensor we use and what type of output it's giving. Okay, so that we can understand. See, so now set flow was 15, result flow 50 we have achieved. Correct. So in between we also give some disturbance, and in spite of disturbance also we have achieved the desired value of flow. Clear? Okay. So now, what are we doing? Now we are going for second phase. So we are increasing the temperature. Okay, so we are using SSR. Do you know what SSR? Solid state release, right? So actually we are using SSR, and by using SSR we are making heater on 100% firing we are doing. So we are getting full support to the heater, right? So where heaters are kept, already I show you that. Now I don't want to go back. In that heaters are kept, I will show you afterwards also. So now we are increasing the temperature in that pipe. So air temperature will increase. So now, if you increase the temperature, then can you tell what will happen to this system? Whether it will affect the system? Will it affect the system? If you increase the temperature, will it affect the system behavior or system?
Yes.
Okay, why?
Due to the pressure, lesser meter pressure, temperature pressure.
Okay. See, ultimately here you are measuring what? Mass flow rate, kg per hour. Correct? So when you increase the temperature, obviously density is going to change, so mass is going to change. But here system is working in closed loop. So when system is working in closed loop, you need to maintain the actual value of output, and actual value of output should be same as that of desired value of output. So control will not allow the variation in that. If some variation happens and it will do something, so the variation will be reduced or it may be omitted or avoided. Correct? Clear? But change are going to happen because we are increasing the temperature. Because it's air, right? So when you heat up the air, it's going to be lighter. Same fundamental we are using in hot air balloon also. So when it's going to be lighter, your mass flow is going to decrease. So that's why control system should increase that mass flow. So how it can increase the mass flow? I hope this is clear. See, typically what happened? Earlier we are working the normal temperature. Now we are increasing the temperature. We are increasing the temperature of the air. Correct? So now, when you increase the temperature of the air, so air is going to be lighter. So since air is going to be lighter, your actual mass flow is going to decrease. But system is working in closed loop. It try to maintain the actual mass flow. It should be same as your desired mass flow. So how it will maintain that?
Increase the speed.
Increase the motor speed. Yes, that's what I was looking for. So now this is the motor speed. It's 1867 RPM. Okay, it's on 1867 RPM, and flow is 49.88. Desired flow is 50 kg per hour. So now we are making heater on, and you can see the temperature one is 2780. Temperature is 29.31 degrees. So this first temperature sensor we kept at here, like when we are seeing the blower. I'll show you that. It's at first end, and second is at the outer end, about just before the HOV. So this is kept at HOV side, and this kept initial. So this is initial temperature. This is the final temperature. So initial temperature will remain same. The final temperature will change. Final temperature will change. Let us see that. So let us make the SSR on. See, so this was what I was talking about. Heaters are here inside, and one sensor was here and one is here. This is one sensor. I can show that in photograph. So now see speed, how much it was? 1867. And what is the temperature to? 29 point something. Now it's increasing. See, become 31, 30. Some variation happen here also because actually, although it's going that will also making contact with it. That's why there is some variation, but that will not be much. See this part. See, what we can see here, number one, speed is increasing. There is no variation means not much variation in the actual flow. Desired flow is 50, actual flow is varying, but that effect is nullified. See, problem is staying, but that is nullified. More or less it's nullified. And that is nullified because your blower speed is increasing. It's nullified because blower speed is increasing. See, earlier it was how much? 1867. Now it's becoming 1900. Why? Because this is, see, it's become 42 degree. It was 30 degree, now it's 42 degree. So this temperature is varying. Because of that, mass flow rate will decrease, but we don't want control system won't allow it to decrease. That's why it will increase its speed. So speed is increasing. Speed is increasing in such a way that it will be maintained. So how long it will be achieved, or how long it will maintain that? Till maximum speed, right? Because once it reaches to maximum speed and then if temperature increases, then mass flow rate will not be maintained. It will be maintained up to that range only. It will be maintained up to that range only. Let's see, we went to 49 point something. Actually, if you have tried this for a huge range, up to 100 degree we went, but it was achieved nicely. Okay. Now number 2. Now we are going for the, okay. So that was I was talking about. So we went for 51 degree. The speed is increased, but actually it is maintained. So likewise, it will go. You can keep on doing it till it achieve its maximum speed. Fine. See, if it is water, then temperature won't go above 100 degree because it's going to be steam, right? So in air, you tried up to that, but speed was not increasing; it's maintained nicely. Now in the same setup, we are going for one more thing. So any doubt in this? So after that, I'll show you how to implement that. So how to implement that, we will see in the next part. But before that, we'll just see one more control, that is speed control. Fine. So any questions for this? Let's keep some going. Now we are going for the speed control. Here, speed loop. So here in speed control, again we are having two things. One is actual speed, second is the desired speed. So you set say 200 RPM. You make it on. It will be achieved. So you can see that same thing on SCADA also. You can see the same speed on SCADA also. So here, whatever speed you want, that will be achieved. So, do you think it's simple? Is it simple? See, it seems to be simple, but before 10 years it was not simple. Why? Because we are using the induction motor. And induction motor is considered to be a constant speed machine. Correct? Speed variation you can achieve by only varying the voltage and some other strategies, but not the way we achieve the DC motors. It's not so easy to change the speed of the induction motor, and most plug-in motors induction motor only. That already know. Correct? So if you achieved it, turn on it. Correct? So likewise, you also achieve the control over pressure, temperature. So 4 control you have done: flow, temperature, pressure, and speed. So now question is how you have done that, how to implement it. To know about implementation, you need to know something about automation, because here actually you have done the automation. So anyone knows what do you mean by automation? Any idea? What do you mean by automation? Any idea? One of the growing field, and which is in great demand nowadays. If I consider our cases, every time company comes, we need student, but students are not available. That's the case. So anyone can tell what is automation? Here actually we have done automation only, because we are just clicking on the SCADA, everything is happening automatically. We are not involved at all. We are just clicking on the SCADA only, everything happens automatically. So anyone can explain this? Does anyone can convey what they mean by automation?
Deviation in the desired output is controlled by automatically.
Deviation, okay, correct, some extent, right? Anyone else? That is right.
Can be achieved without human intervention.
See, normally you can't omit the human. Human will be there somewhere. Maybe they might be contributing 1%, 2%, 3%, but they will be there. Without human, rarely something is like you can expect. Something will be there. At the start command, they will be giving. Boss will be the human. See, now we are doing so many automated gadgets in our home, but boss will be human only. Right? So human will be there, like that is true, but whatever I say, that is also correct. See, if we go from scratch, automation means actually a delegation of work done by the human to some machine, equipment, device. Means whatever work that we do, if we delegate that to some machine or to equipment, it's going to be automation. The simplest example is ATM machine. Earlier, to withdraw the money or to deposit the money, we need to rely on the bank clerks. Before 10 years, I am talking, 10, 15 years. So now, we can do that very easily by the machine. So that work of clerk was delegated to the machine, to the ATM machines. Correct? So here ultimately actually you have done automation only. Why? I am saying it's automation because earlier what was our aim? You start with our next example, our main example. We want to control the flow. And then we went there and we have varied. But when we varied, like what madam said, at the time we might not be controlled exactly to 50. We might put the bar at 55, we might put the bar at 45. So you can't do, means we can do, but we might not be able to do exactly or accurately. So that's why you have to delegate work to some machine, to some equipment. And also one more problem is that if you have to control the 24/7, that somebody should be there 24/7. Right? Like if I want to withdraw and deposit the money 24/7, then clock should be there for 24/7, but it's not feasible possible. That's why we are delegated work to some machine, to some equipment. Correct? Same thing we are doing over here. So let us understand the automation quickly by taking a very simple example. So now we are going for the implementation of it, means real engineering of it. Okay. Let us take one simple example. Very simple example, maybe you can say school level example, and from school level example we will go towards engineering. Okay. So our aim is we need to maintain this height h fully manually, 10% manually. How will you do? Or how will you do? We need to maintain the height h fully manually, and both walls are on-off type of wall, just for simplicity. Like you can make it fully on and you can make it fully off. And when you make it fully on, flow is same. Flow is same. Surprisingly, or maybe pressure is same, that's why we are getting same flow. Right? So, how will you maintain the height fully manually?
Continuously observing the height.
Outlet valve is closed completely.
Hmm?
Outlet valve closed completely, and inlet valve one open.
Hmm?
Make somebody stand there.
When height
No, okay, yeah, then, yeah, fine. Then,
when height reach
To that
inlet
level.
valve will close.
Okay, can't be operated. What about outlet one? Closed only?
It may be anything, but we need to continuously monitoring that height edge.
No,
Whatever.
actually, before you do that, no, you need to know what the process exactly what happening and for what purpose they are using. See, when we got some project from some client or some company, they might not be telling everything to us, but you have to ask them. Okay, you are using for what purpose? For example, this is some overhead tank which you kept in some big building terrace, and from that, suppose this is the main wall, and from that connections are taken from so many homes. For example, it's taken from so many homes, and this is a master wall, and this is a one more wall which is going inlet, like a free flow line. Because you know, if it's motorized, then you can't make it off. Only motorized, then you can't make it off. Otherwise, it will put a lot of back pressure on the motor. Like what you say, you know, that's possible. But in air blower, actually, we have gone for that air blower, so in that pressure won't come because it's centrifugal time. So back pressure won't come. It will just rotate with free air. So here, what happened actually? So suppose it's something like that. So where you can turn off this wall and this wall. Correct? So what we have considered, this is a tank which is overhead tank, maybe somewhere. This is a master wall. Once you close it, connection to all the lines will stop, and from here so many lines might be taken. Correct? And this is the inlet wall. Inlet same HOV, you can make it fully on and you can make it fully off. And you have to control the height manually. So now you tell me, what will do? What will do? What are you saying that is correct initially, right? Initially you make this wall off, you fill the tank up to high dash, then when you open this wall, V2, will it be over? Will it be over?
No, I have to maintain the height.
But how?
We
Like,
have to set
then
some
both the
liquid
valve
level,
has to
maintain the rate of flow.
liquid
Need to keep some
system, right?
sensor, inlet and outlet flow.
Manually slowly wait करो पानी जरा height के नीचे आ जाओ तो height के नीचे पहुंच जाओ
By continuously observing the height,
हाँ
you have to maintain the inlet.
every that this is only possible.
okay, yeah. Number one conclusion. First we on the wall, like once we on the wall 2, can you operate? Theoretically and practically.
No.
Theoretically yes, practically no. Correct? Because obviously suppose it's
Yes, yes.
taken from so many homes, you can't make the connection
That
of
bottom
any
are
persons.
close. It's always open.
So once you say it on, you can't make it off. In emergency you can make it. That's why I said theoretically it's possible, but practically it's not possible. So practically we can't make it off. So it means that whatever height you want to control, that has to be controlled only by varying wall one only.
One.
Inlet wall.
Correct? Inlet one only. That is conclusion number 1. Or we can say conclusion number 2. Okay. So now how will you do it now? Somebody say it actually.
Turning it on and off.
Slow कर slow. Outlet valve को slow करो.
Okay, that if you do that, pressure will drop at other time. That we can't do.
By monitoring the height.
By monitoring height, we can manually turning it on and turning
Very
it
good,
off.
right? We can do manually, right?
Yeah, nothing
Yeah.
to that.
Suppose you want to maintain this height, say. So conclusion is very clear. Like first conclusion, once we make the wall on, we can't make it off. Second, we need to maintain that only by varying V1, right? Third, we will keep on observing the height edge. We'll keep on observing the height edge. And when height fall, then we'll
Turn it on.
open the wall. And when height increases, we'll turn off it. So now in which case it will increase? In which case it will increase? Because both are in same flow, that's what I said. Like when you make this fully on, this fully off, when both are fully on, then flow is same, that's what we assume. So in which case height will increase?
When there is no observation.
चालू करो नहीं जो देखो
So in which case it will increase?
If both the flows
See.
are same, then it is not possible
Then not
manually.
it is.
You have to
It's
increase.
possible, I tell you how. Suppose see, already told that from here so many connections are taken. Suppose all home supply is off. Although this wall is on, all home supply is off. In that case it will increase.
Temperature.
Correct? Maybe in the night time, maybe in the afternoon time when nobody is there at the home. Somewhere maybe. Possible, maybe possible. Correct? So it means that this height may fall or it may go up. That's what you want to convey actually. And this happens in process also. Suppose this goes to various processes, no? And some process will take the water as per the requirement. For example, you have dishwasher, they need to take the water as per its requirement. Already you conducted, you already make the tap on. And you just take the water as per its requirement only. It's not like that every time it will take. It takes for some time, whatever it needs, take it. Same thing like that over here also. Here suppose so many taps are taken, this master also, if all was this all, although there also material might not flow because other connections are off. Correct? So conclusion is it may go down. So if it is going up, then obviously you can make it off. If it's going down, then you can make it on. Very simple. Very simple. So to do it 24/7, how many persons are required? Tell me. To do it 24/7, how many persons are required?
Per household.
Tell me now.
सर वो मैंने सीरियल को हम दिया
3 shifts per day.
Tell me.
नहीं वो मैंने बोला सही
Yeah. So to do 24/7, how many persons are required?
For being it's only 2, but
For shift 3%, 3 shifts are required.
Yeah. If you go by the laws, you can't make anyone to work. Labor class, I'm saying, not our class. Labor class should not be work more than 8 hours, right? So 8 hours. So it means you need 3%. 3% into.
That is on the first one, to operate it first one.
So I'll say if they will do both the was like they will fail first of them, they'll do it maybe. Some accuracy, maybe suppose we can dial. Will not go for more good accuracy, but with some accuracy we'll do it. For example, some deviation will be there. So 3% will do.
Number of houses.
No, house is like it's from here.
इंडिया का नहीं
It's from here, so we just need to control this only. That's all.
Maybe both the valves locations are.
Maybe it's near, maybe it's not far. Maybe it's not far. I mean, somebody can do. Just go there, they can do. Some accuracy will be lost because of that. We agree, we accept it. No problem. So 3% will do. Hi Anna. Yes, hello.
yes
No. What about holidays? Nobody work for 7 days per week, right? Who will work for 7 days except us? Leave us. Don't count us. Okay. Nobody work for 7 days per week. So at least we need around 4 to 5%. Depends on how you optimize. So suppose, see, why I am telling this is, suppose you need 4 persons, and how much are you going to pay to the 1 person per month? See, whenever you go for any technical design, you also see the commercial part of it. If whatever you make, if that is not sellable, if the design has no society value, then it's of no use. Correct? See, now we are going to some train like Vande Bharat. The main purpose is the cost reduction, because if you import the same train from European country, it costs around 50 crore. But our country has made it in around 97 crore. See the difference in the loss. In 250 crore, they will get 2.5 train. Right? See. So if something is economical, something is so commercial, but it will always come in with any technical design. You believe or don't believe, but this is fact. Correct? See with the mobile phone also, one company is making mobile with 1 lakh rupees, same mobile, almost same thing. Everything is 10,000 or 10,000 companies also getting also very famous. I don't want to speak name of the company in front of the camera, but you can understand what I'm saying. Right? So if design is good, if it's economical, people will prefer. Right? So same thing here. So whenever we do any technical design, we need to see the commercial aspect also. To see the commercial aspect also. So now 4% you are doing, how much you going to pay to the 1 person per month? If you see the government rule, you know government rule and daily wage rate, and if you see with that rate, it's going to be very, very high. Like our government rate, if you see, no. But suppose just for calculation, suppose you see, say it's we are going to pay around say 8,000 rupees per month, then it's going to be 32k per month. For 12 months, suppose how much? For 12
nearly
months?
4 lakh 4 lakh nearly
Around 4 lakh rupees per year. See, this is only for might be there. So it will be huge cost. So here we need to delegate this work of human to some machine to some equipment. So we need to do the automation over here. Correct? So how we do the automation over here? So normally whenever we do the automation for any system, normally we observe how persons are working on it. Correct? So here what first thing we have done? Very first thing that we have done is we have observed the height.
Yes.
Correct? So which part of our body was used to observe the height?
I.
Eyes. So you will replace this work of height to some, or you will delegated work. So that's what I say. Automation means delegation, means to give the delegation of work done by the human to some machine, to some equipment, to some device. That's what we have to do. So you replace the work of height, or you delegate the work of height to some sensor. You put some sensor over here. It can see the height. Which can see the height. Correct? So definitely here you can go for some sensor. It could be any sensor. You can go for capacitive sensor. You can go for ultrasonic. You can go for any type like a vibrating fork. Yeah, any level sensor you can go for it, and you can go for the sensor here. So you put the sensor over here. So that sensor output or our eye output was going where, or from after seeing the height, where signal was going in our case when we were controlling manually.
Head.
Head means
Brain.
brain, right? So you also need to put some brain. Without brain, it's not going to work. So as a brain, what to consider? Controller. Correct? So you put some controller. So the signal of sensor will go to the controller. Correct? And controller is also receiving one more signal or one more information. Which information? Or our body also, like when we were controlling manually, we also have one more information. Which information we were having?
Position of valve.
Actual height, what that we want to measure. Set height we know, right? Set height we were knowing. So here also, this actual height will be compared with the set height. So that comparison you should do in the controller. And that controller will give output to the. So that's what after comparing that in brain, what we did, we were just commanding our hand to open or close the wall. So that controller should give output to the wall. Correct? So it means it will look somewhat like this. So now you understood as a sensor, you can go for any level sensor for this application. Suppose in some application you are measuring pressure, then you can go for pressure sensor. In some application you are going for the flow, then you can go for flow sensor. And signal will go to the controller. So now question arises. As a controller, what you will choose? And what you choose as a controller? Like there are so many controllers available, no? So what you will put practically in this block?
Comparator.
Practically what you will put in the controller. Here actually we are not only comparing, we are doing other thing also. Like we are making motor on off, other thing also we are doing. So as a controller, what you will put? Practically. Okay, in AC what control we are having? No, in AC we are doing so many things, no? Like in AC we are controlling the temperature, we are controlling the position of that flip and all the thing. Right? We are controlling the speed of the fan also. See, temperature and speed of the fan is different. Already we know. So all we are controlling from the remote. Correct? So now as a controller, what is there in the AC? Any idea? Or whether control will be there in this? Do we have control in the AC? Do you have control in the AC? So, question arises, control is there or not? It will be there, right? It will be there. Without it, it's not possible to control. You are controlling, mainly the temperature you are controlling. So here as a controller, what you will put? Or what controllers are universally people are using? Any idea or any discussion on it? Huh? So like what you consider as a controller? Like what you consider as a controller? Because practically you want to design. It's not like we are designing on the simulation. We are doing practically. You want to make the system practically ready. Then only you can replace the human. No. I can replace the clerk with the ATM machine when ATM machine is practically available. Not in the simulation, not in the MATLAB or some simulation. It should be readily available.
Open or closing the valve.
Hmm.
For that, we are controlling.
Huh?
We are controlling the opening or closing.
Correct,
the valve.
correct. So, but yeah, correct. But for that, what type of controller you will prefer, or what controller you will use?
कंट्रोलर के पास ये सब हैंडल करने के लिए
Okay, you will go for PLC. Okay, fine. Apart from that, so do you know what controllers are there? Like people are using universally.
Open comparator.
Okay. First, suppose microcontroller, right? Yesterday, sir has considered. Sir went up to STM32. STM32 is microcontroller. Correct? But see, now microcontroller where it came after which year?
प्रोसेसर
No, after which year it came into the service existence? In after which year? Which year? Any idea? 19?
76.
76.
Micro 805, 8085. Processor.
Processor, okay, MUP. Okay, so after, see, because first transistor was made in 50s actually, commercialization done in 60s. So music came in around 70s, 80s. So see, do you think before 80s there was no control strategies, like no control systems? See, we have submarines before that also. We have aircraft before that also. We have the huge machinery in the industries before that also.
रेडियो इज आल्सो
Huh?
रेडियो
Yeah, even your big cruise like Titanic was a big cruise. In this, so many things are automated. It was also there. So it means there were some other controls, and that was actually a hardware. Means in hardware means in a low language actually do not have any software part. It's only hardware. All physical components are there to make some logic. All physical. There is no software part. Whereas here in music UP onwards, all software parts are there. Okay, all software parts are there. Software and hardware both are there. Then next is PLC. Whatever you say. And next is
DCS
DCS. Yes. Fifth is SCADA is not a controller. Actually, it's a supervisor, right? It's about that. Like if you remove the SCADA, then also system work. It's a supervisor, like supervising controller. It's just used to give some commands. Okay. Next is PC based controller. There are some famous companies which are doing PC based controller.
फुल्ली नहीं
Okay.
आउटपुट वाला में
So now
they fully control
what any doubt?
no
No. What fully controlled?
Actually, we are talking regarding that. Still, it is open loop. We are discussing on that point.
I am saying it is partially closed loop.
Partially, as we are not
Because we are
considering
not
that
sensing the
outlet valve, the rate at which the liquid is flowing. So
Flow we
that
are not controlling. We are just opening and closing the valve.
so based on that, it will also take some more time.
Partially closed loop, I am saying that.
It will take more time to
No,
fill
now
that.
see again, closed loop, open loop depends what actually you're controlling. Suppose you're controlling height, in that case it's a closed loop. If you're maintaining flow, in that case it's not open, it's a open loop only.
Yes. Because we need to
So
also maintain
it all decides based on which quantity you want to control. If you want to maintain the height, then in height sense it's a closed loop.
Yes.
For height it's a closed loop, but for flow it's open loop. That's true. So fifth is PC based controller, and there are some famous company which are doing PC based controller also. So out of this hardware nowadays people are rarely they are using it, or they are using it only in small applications. So UP and USB systems people are using it a lot, but you know in which sector they use it in the lot? Industries, sometime or rarely they use the MUP or USB based system. That MUP music systems are used, you know where? Number one at
household or small application.
household and small application. Okay. Drives. Okay. Good. See,
इनपुट आउटपुट कम चाहिए उधर.
Hiring circle. Hiring circle.
Yeah, fine circuit we are using it, okay, right? Okay, just to understand it, we have time, right? I'll just give you a simple task. Already like it will just suppose you have to design a control strategy for say fully automatic washing machine. Control strategy means what? You have to design some controller where you can use some input and you can use some output. I am not saying you have to design entire structure. Ultimately, our aim is we have to design the controller with some software part where we can easily connect the hardware. So all of the software hardware you have to design. Suppose we have a team of 4 person or maybe 3 person. We have a team of 3 person. Okay, which is designing this. So how much time will be required? So you know how fully automatic washing machine works, right? Initially you do like put the washing powder and other thing washing powder. If it's dishwasher, then you have to put the salt, then that washing powder and other thing. If it's only washing machine, you just need to put a washing powder, that's all, or washing that detergent liquid or whatever. Then you just put the clothes, you close it, you make it on, it will work automatically. That you know, right? So that controller you have to make. So where you can give the input and you can take the output. So how much, and your team of 3 person, how much time suppose somebody will take, or we will take to design that scheme? Any idea? Suppose that those are designing, no, those are designers, they know, like they have some experience of 1 to 2 years. Suppose they are fresh graduates, means after BTech they are doing a job for what, 2 to 3 years, and then they are designing it. There are 3 persons per team and they are designing it. So how much time they would take? How much time they would take? Any idea? 1 month? 15 days? How much? Some reply, huh?
3-5 days to go export.
1 week, right? Okay, fine. Let us take 1 week. Okay, it means that in 1 week, they do testing also? Testing and all design will be over by 1 week? Yes. Okay, fine, very good. Sure. So now, what will be the cost to company for these 3 people? Suppose if the salary is around say 50,000-60,000 per month. So what will be the cost to company? Suppose salary is around 50,000. Only 1 lakh, chalo, it's our students a good salary, so 1 lakh rupees per month, for example. So 3 students means it's a 3 lakh rupees per month. So 1 week means 8 by 4. So 3 by 4 means around 75,000. See, now they are designing the control strategy for washing machine, and cost to company is around 75,000, and the washing machine after making we will sell it at the cost of around 20,000. That's the cost, right? What is the cost of fully automatic washing machine? It's 25,000. So where we are making where we are doing means something wrong in the calculation. What is wrong in this?
The timing taken by the design.
No, maybe correct sometime, that is also true, but there is one more thing. Actually no, this 1 week is very less. Whenever somebody design any system with microcontroller, no, maybe we can ask them, they always take more time, right? Because first they need to do the entire coding. After coding they need to test it, they need to check the hardware properly, and everything will take some time. If expected is 5, but in 5 days it may not be over. That's practically you've seen, it will always exceed the days. And that's why no, many times you might also observe when some student do the BTech project with controller, at the end of day it may not work at all. Sir, it was working before 1 hour, now it's not working. They might tell that also. Correct? So sometimes it may not be reliable also. So it's not reliable because it's not tested properly, that's why. Otherwise, somebody can make reliable system also out of it. It's possible. Correct? So
Mass production.
yeah, so it's a mass production. We can reduce the cost only by doing mass production. So now you observed everywhere. You observed whenever microcontroller systems are there, they're always produced in bulk. They're always produced in mass. Suppose this AC is there of some company, some model. Such ACs are made in lakhs piece per annum by one company. You go buy say POS machine. In POS machine, we are in microcontroller. POS, know that shop people will have that where you scratch your credit card, you just tap your credit card, debit card. It's again having microcontroller. If you go to some that gas person comes, like gas bill person, he just click something and he'll get the bill out. Again, it's a microcontroller. Train, not train, that bus ticket conductors are having that POS machine. Again, it's a mass production. See, wherever you see microcontroller, no, it will be of mass production. The devices are always in mass. You see, any application, maybe somebody will say it's used in huge, that's true, but it's a mass production. Correct? So in company, can I suppose I am having some company which is making biscuit like Parle, can I open some company which can make biscuit exactly like Parle-G? Can I do that? I can't. So other laws are going to come into the picture. I can copy the exact product in the industries I am talking. I can't copy any product. I can make a singular product or singular type of product, but I can't make an exact product in the industries. That's why in industries, mass controllers or mass production is not possible. You have to go for the this. What I'm saying, I'm talking about the product will be produced in mass, but the way you are producing that product, one product will be unique to the other product. In that way, I'm saying. So that's why you need to have a different control strategy for each product. That's why you need to go for the tailor-made designing. So what is the meaning of tailor-made design? Tailor-made design means the design is made only for that company. Like for example, somebody made a design for some company, say Parle-G, then that strategy will not be used for the Britannia. Because in India, you know, number one is Parle-G, number two is Britannia. One is public limited, one is private. Right? So tailor-made design you need to have. Whenever you need your tailor-made design, no, the base controller people prefer is PLC. So I hope you understand the meaning of tailor-made, right? The base example of tailor-made is in the suit and in the kafni. So people say that if suit is not tailor-made, then suit will not suit you. Ready-made suit you can't purchase. It should suit you, right? Same with the kafni also. So that's why special design for you only. Same with the company product also. Special design for that person or that company only. So whenever you want to go for tailor-made design, then we need to go for PLC. So now you go to any industries, wherever you see some machine or some equipment, you will find PLCs in that. You go to RE, which is making solar panel, but that panel, no, that machines are doing some work, having PLC. You go to any industries, you will find it. I'm not saying you won't find microcontroller-based system, but they are there for the mass production side. It will be there. Correct? So I hope. So it means both are having different class of application. Application class is different. So where we are going to use PLC, that museum people want this, and where we are using this, that PLC people want this. It's a different class. So in industries, it's a specially designed for specially product, so it will be PLC. And industries might also use a DCS. In many sugar factories like Anthar and here also Bottle sugar factories, they have DCS. They are having DCS. Okay. So I think we'll break for 2 minutes. We just have our tea.
Sir, we need to break rapidly.
So see now, as a control, we are going to use this 5 things. Okay. You go anywhere in the world, as a control, you will find this only. Out of 5, 1 will be always there. Correct? So, control output will operate this valve, that's what this diagram says, but actually practically it is not true. The reason is, whatever your control you have discussed, apart from the first one, all are electronics based. All are electronics based. All are electronics controllers. So whenever you talk about electronics controller, they are very poor in power output, or they are very poor in power delivery. Okay. So directly they cannot operate this valve. This could be a SOV, this could be MOV. MOV means motor is operated valve. You might be operating the valve with some stepper motor, servo motor, or some induction motor sometime. It may not be operated them directly. So in that case, you need to go for some device in between, that is called actually actuator. So anyone knows about actuator? Anyone knows about actuator? Okay. If you are not 1 ampere switch 220 volt, and we have one heater 1000 watt 220 volt 50 hertz, and we have a supply 220 volt. So now our aim is, when you switch on, heater should be on, and when you switch off, heater should be off. Aim is very simple. When you switch on, heater should be on, and when you switch off, heater should be off. So can you draw circuit for that? Now I think just try to phrase yourself, like can you draw the circuit for that? Task is clear, right? So when you switch on, heater should be on, and when you switch off, heater should be off. I think all of you or maximum of you are from electrical or allied branches, so I think you can try. You may try. So this will justify the need of actuator actually. Okay. What is this?
contact I use there. This is normally open contact. Maybe I switch on person. I push button में जैसे switch on है ये file लेने जाए क्या contact close थी खाली कैसे ये क्या करो किस switch.
Okay. Suppose you make some circuit like this.
समझी गया.
So will it work? Will it work? Will it work? It won't work at all. The reason, as soon as you make the switch on, no. After some time, switch will blow.
Yes.
Why?
Correct.
Why? Because 1 ampere is the maximum current that 1 ampere is the maximum current that your switch can carry. 1 ampere is the maximum current that your switch can carry. Correct? Why? Because if you just put the equation, see, like whenever you talk about designing, it starts from the
1000 divided by 220.
VI cos theta, for example. Suppose it's a resistance, so you assume power factor 1. So V 220, I we don't know, cos theta 1, power we know 1000 watt. So I is about 4.7 ampere maybe, I don't know. Right, around 4.7 ampere. So as soon as you switch on, your switch will blow off. So means this tendency will not work at all. Correct? Because reason already know. So in that case, you need to go for some actuator. So here you can go for any actuator. So one of the very famous actuators is relay. The relay, it's not a relay which we use for production. The relay which we use for control purpose. Correct? So in the relay, basically what we have one coil and sets of contact. I have just shown only one contact. So the benefit is this contact and the coils are connected magnetically. It's connected magnetically. So when you energize this coil, this contact will be pulled and it will be closed. And when you de-energize this coil, it will be, this contact will come to its original position. Right? So now benefit is the current requirement of this coil is somewhat less, around 100 milliampere or something. Whereas this around 100 milliampere, you can say. Whereas your contact can carry around 5 to 10 amperes of current. Correct? So by using actuator, you can easily do it. So here, if you want to operate it, then what you can do? You can connect this to the coil So this is actually actuator. So I can say maximum time after controller you have actuator. It could be relay, it could be contactor, it could be VFD. VFD is also one of the actuator only. VFD, or you can say VVVFD, variable voltage, variable frequency drive. It is also actuator. So every time you can see after controller you will have actuators. So without actuator it is not possible, because see, you can easily understand, because when I switch on AC from the remote, obviously supply is not coming from supply to remote and remote to the AC, right? Something is happening there. So when you switch on internally, it will just make some actuator on, control will make the actuator on, and from actuator supply is going to flow. So that's why there we have to separate circuit. One is control circuit, second is power circuit. If you have seen any diagram, if any diagram of any washing machine or somewhere, there very clearly they written control circuit, power circuit. And control circuit normally works with the low voltage, relatively low voltage, and power circuit work with the as per the power requirement. Everywhere it is more or less same thing. In AC also we have the same thing. We have control and power both separately. Correct? So here you use the actuator. So just to tell you this, I have taken this simple slide. So after control it will be always actuator. Correct? Okay. Any question, any doubt? So practical relay will look like this. Correct? So when you club all the thing, like this is a relay. Here we have so many contacts. Sometimes we have 2 contacts, 3 contacts possible. So when you club it, it's going to be this. Actually, it is nothing but a closed loop control. So actually, whenever you do automation, no, more or less you are doing closed loop control. Correct? Whenever you do automation, you are doing normally closed loop control. But here only thing is, here comparator is shown outside, because in all our books it's shown outside, that's why. But practically when you see, no, this comparison actually done by the controller itself. Controller is only doing the comparison. It's not done outside the controller. Like it will be something like this. Correct? So this is a more practical diagram. Because after controller and comparator is also done by the controller itself. It's a part of control only. This logic will be also like, logic means the program that you write. It will be also in the controller. And it always gives signal to the actuator. And actuator will operate the final control element. Correct? And the set point, we give it from the normally HMI or SCADA. HMI means human machine interface. SCADA means supervisory control and data acquisition. Like the PC which we used, it will act as a SCADA. We click on the SCADA, and with that set point we are giving. From there only we are making motor on and off and all that. Correct? So if you can know how to make this for our system, then we can make that automatic. Like you again recall, our task is only one. Our task is only one. That we can make very easily. Correct? Yeah. So any doubt up to this? So now can you tell me how we can design that? Like what we are going to put as a controller, as an actuator, as a like system, what we'll be having? Same application, same airboard system. We want to control the flow. So system what we are having? We are having the one induction motor. So it's connected with we are having the controller. Clear? So what we'll put? So we are having the induction motor which is working with the air blower, which is blowing the air with the pipe. So we want to control the flow. So what we need first? Blower is there because it's a part of system, right?
Flow sensor.
First we need to have a flow sensor. So as a flow sensor, we have gone for the orifice. So you know maybe somebody might be doing the working of orifice. Orifice will work with the differential pressure. Right? In that actually what happened? Let us give you the very suppose there is one pipe, and if you create some disturbance here, then then here there will be more pressure, here there will be less pressure. And the amount of pressure or the whatever the pressure difference, that depends on the amount of flow. If there is a more flow, then there will be more pressure. There is a relationship between the pressure and the flow. So based on that, actually in orifice we will calculate the flow. And actually the orifice calculation also depends on temperature. That's why some temperature sensors also attached with it. Correct? So you will put one flow sensor to measure the flow. So that flow sensor will give signal to the controller. Fine? Okay. Then we will enter the flow from set flow from SCADA. And how you can change the flow? How you can increase or decrease the flow?
Speed sensor. Water.
By speed sensor, not exactly. How you can increase or decrease the flow?
Opening or closing the valve.
No, what we are not touching, we are doing automatically. Now you have to control it automatically. No, like whatever we entered in that, you are not operating the valve. That also we can do, no problem. But now you have to do it automatically. So in that, ultimately you have to change the speed. You need to increase or decrease the speed. So again you understand, we need to increase or decrease the speed of what? Of induction motor. An induction motor is actually constant speed machine. Why it's constant speed machine? Because you see the equation of speed. Ns is 120 F by P. Then synchronous speed. What is actual speed? Ns1 minus S. Correct? So Ns is actually, it seems here FFP seems to be variable, but actually practically it may not be variable because once you make the motor, the poles are fixed. And GB or supply frequency is always same. Correct? So that's why your speed will be always, synchronous speed will be always fixed. So because of that, your this speed will be always fixed. The only way you can change the frequency, the speed is maybe you can change the F. But you already know only F you can't vary. Along with F you also need to vary the V. What is the reason? Along with F you also need to vary the V. Why? Why we need to maintain, or other question is why we need to maintain V by F ratio? One of the very famous questions for the interviews. Why we need to maintain V by F ratios?
5.
Correct. Maximum flux is constant, right? That's why we need to maintain the. So only frequency reduction will not help because if you decrease the frequency, your if you need to also decrease the voltage. The ratio you have to maintain. Otherwise, maximum flux
Saturation.
it will get saturated. And if you go to saturation, it will be a lot of what is the drawback of saturation?
No
It's going to be
transformation of that.
flattened. It's not. It's going to be a square wave.
Yes.
And if it's going to square wave, it's going to produce
Heat.
lot of
Harmonics.
harmonics. Lot of harmonics means lot of heat.
Yes. Harmonics.
Correct. So that's why we have to go for. So now we have to get the speed of induction motor. So only option is, or one of the good option is, you can go with VFD. So as an actuator here, we have gone for the VFD. Correct? You are measuring the flow. If flow is not as per your requirement, then you need to increase or decrease the speed. And that calculation we are doing where in the program, in the PLC, and based on that calculation we are increasing or decreasing the speed through VFD. I'll tell you, I'll do some introduction about VFD also if time permits. I'll do some introduction of practical VFD. Correct? So we'll get like this. This is a simple example that is just to tell you how suppose somebody want to maintain the temperature and what they can do. They can put some temperature sensor. It could be RTD or thermocouple or whatever. They need to put a transmitter because transmitter is needed just to maintain the signal. Like whatever signal is required by the PLC, that has to be given. So all sensor will give different output, depends on the sensor properties. Like RTD will give the changing resistance, thermocouple will give the changing millivolt, and PLC needs something else. So that's why you can go for transmitter which can give the standard instrumentation signal. It could be 0 to 10 volt or 4 to 20 milliampere. So all sensor in the world, like whatever you use with the controllers, PLC and DCS, will always need a standard signals. It could be 4 to 20 milliampere. It could be 0 to 10, mainly. Right? So just to achieve that, we use the transmitter. So actual here, set temperature we are giving it from here. So based on that, this contactor is again one of the actuator. It is just like a relay. Working principle is very close to relay. Only thing is current carrying capacity is huge. It will make heater on or off. It will make heater on or off. So like as you can maintain the temperature. Similar way, here we have done the similar way we have maintained the flow over here. So this is a photo of it, air blower. This is a photo of flow sensor. So they will give signal to this panel. This panel will again, I think it will be there. Here it's somewhat more visibly clearly visible. This is a temperature sensor which is used for the internal calculation of the flow. This is a pressure sensor. Here this is actually, anyone knows? It's known siphon. Siphon is basically used whenever working temperature is high. Because see, nowadays maximum sensors are using electronics, and whenever you go for electronics, they are not able to withstand more temperature. So if you are working with the more temperature, then you have to decrease the temperature. That's why we are using the siphon. So siphon will just increase surface area, and then it will increase the temperature. Because here sometimes you work with more than 100 degree, and no electronics circuit or it will work for that temperature. 55, 60 is the limit for maximum devices. Right? That's why we are using this siphon. Fine. So this is the panel. The indoor part. So PLC, your sensor signals. Basically, two sensors we have to use. Or maybe if you go for first case, we have to use two sensors. One is speed sensor. Speed you are measuring by pitch sensor. How you can measure the speed?
Encoder.
Encoder. So which type of encoder we are going to use?
Rotary.
Rotary. There are actually two types of encoder. Both are rotary. One is absolute, second is incremental. So we are going to use incremental encoder. And incremental encoder, they are in the PPR, pulse per revolution. So you can go for 360 PPR or multiple of that PPR. 1080 or something. So that pulse PPR means that much pulse per revolution it will give. So whatever pulse it give, it has to be catched by the controller to understand the speed or to know the speed. Correct? So all sensor output will be connected as an input to the controller. So based on that sensor input and based on the set value and based on the program written and based on the execution of it, it will produce the output. And then output will be in the what form? It will be in the form of varying the speed. So here what it would be or what will be what it will be this way. Just for understanding, I'll explain. From PLC, suppose we are going to out 0 to 10 volt. So that 0 to 10 volt is connected to the VFD because VFD will act as actuator. This is VFD. Yaska or VFD we have used. Messing PLC we have used. Messing is now taken over by the Mitsubishi. Now it's become Mitsubishi. Earlier it was Messing. Messing PLC, Mitsubishi. Now it's Mitsubishi. Yaskawa VFD we have used. And whenever you use the VFD, it's better to use the chalk because VFD will produce a lot of harmonics. Or whenever you use any power electronics components, you always prefer that you use the chalk. Otherwise, it will spoil the power quality. Correct? So that's why you're using the chalk here. This is all MCB, SMPS, just to give the proper supply to the PLCs. Control transformer, connector, so above this, all will be connected in the parallel. Below this will be coming from the external world. Whatever wire or cables are connected to the other, like outside the panel, will be connected at the bottom of it, and above it will be inside the panel. Correct? It's a very small panel. Any question? Okay. It's a very small panel. So that we are doing. And this is SSR. This is used to fire the heater. Like when you turn on, like again here we can use 0 to 10 volt. 0 to 10 volt is mapped to 0 to 10 volt is mapped to 0 to 20 volt. 100% firing and it will receive 220 watt. So 220 watt will receive the heater, so it will work in that way. Okay. Correct? So this is more clear photograph. PLC, chalk, control transformer, filter, SMPS, MCBs, SSR, VFD. Correct? And you know what is the flow. So this is the practical diagram. Correct? Set point, flow set point, whatever you are giving, 100 kg or 50 kg, that you are going to give from the SCADA. And so that will go to the PLC. PLC has one more thing, this program is already loaded in this. You already have downloaded the program. From flow, you are measuring the flow and it will go to the PLC. It will be compared there. Based on that, it will make motor speed up and down. So it signal will go to the VFD. VFD, this signal will go. Which signal? 0 to 10 watt is connected to the 0 to 50 hertz. So if you want to run the motor at the full speed, you do 10 watt. So if you do 10 watt, motor will go with the full speed. If you do 5 watt, it will run with the less speed. So who will decide this? How much watt you have to give? Who will decide this? PLC. In the PLC, actually we use the PID only. Although, many will not prefer PID, but maximum work in industries are done by the PID only. So with PID, we have achieved it. So voltage, maybe sometimes 5.6 to 5.8, 8.7 to whatever voltage is required, that is decided by the PID. So that's why once you do the tuning, no. Ultimately, final output is the voltage output from the PLC. So and that only will be out from the PLC analog output. Basically, PLC has two type of input. One is digital input, second is analog input, and two type of output. One is analog output and digital output. So here we use the digital output of the PLC. So digital output of the PLC will act as an input to the VFD. So this is the output of the PLC, digital analog output in the form of 0 to 10 watt. So this 0 to 10 watt is connected to the VFD, and the 0 corresponding to 0 hertz frequency and 10 watt corresponding to the 50 hertz frequency. So actually this you have given to the frequency set point of the VFD. Anybody is involved with the practical VFD? Anybody has operated some motor with the VFD? Like
ये सेम सेटअप हमारे यहाँ है सर यहाँ पे
We are
yeah, right? That's good. But you operated it.
not working right now, but
No, only that is the difference. Different very many. So anybody operated a motor from the VFD like
पहले किया था
must have.
so like some parameter change and somebody is operated? No, because no, now that is used a lot. Like if somebody know only VFD and configuration motor, they'll get like some student may get very good job.
Maybe manually changing the frequency and
वो फ्लो भी हम पहले कंट्रोल करते थे वाल क्लोज
Manually.
हाँ तो VFD का फ्रीक्वेंसी अपने आप ही चेंज होता था
Okay.
जैसे ये फ्लो हम वाल क्लोज कर देते थे पूरा नहीं थोड़ा रहने देते थे तो उसकी वजह से हमको तो फिलअप ज़्यादा करना था तो VFD अपने आप वो करेक्ट आउट करता था
That's good. Yes. Yeah. Okay. So actually no, I'll just give some introduction of VFD so it will be clear. So it's not a problem. But ultimately no, we have done in this way. This 0 to 10 watt was connected to the frequency set point. So it's actually we have used the analog input of the VFD, and that is configured as a frequency set point. So when you do 0 watt, it receives 0 frequency, and when you do 10 watt, it receives 50 hertz. Correct? So and that 0 to 10 watt, that range will be decided by the PLC program. And for a PLC program, we have used the VFD routine. We have used the PID. Correct? So accordingly, to control this. Correct? So now what is missed in this? Now you need to know how to configure the VFD and how to program the PLC. And that is like, it's not like you have some idea that you can do that. It's not tough at all. implement it entire thing. So now, for example, you want to control the, say, here this is the for flow, right? Suppose now you want to control the, say, speed of the motor, then how will you do? You enter some speed, no, second part of your zone. Second, suppose you enter speed from the SCADA, say 1000 RPM, 1200 RPM. We said 1200 RPM. So how will you achieve it?
We are sensing the speed via encoder.
Yes. In that case, what we need to do? Do the same setup, but instead of measuring the speed, instead of measuring the flow, you need to measure the speed, and you have some different program. You have some different program, or maybe all four program will be together only, but at one point only one will be work. But and that speed again, speed will be achieved by the VFD only. Correct? Similarly, suppose you want to maintain temperature then.
Temperature sensor.
How?
Temperature sensor.
Because see again, you make the heater on. There are two way actually. There are two way. SSR we are working in the open loop. We have to set the values. There is no control over it. Like manually you can make it on. Once you make it on and then you want to control the temperature of there, then only thing is you can manage the temperature only by increasing or decreasing the flow of the air. Correct? You can only maintain it by increasing or decreasing the flow of the air. So in that case again, you have to measure the temperature. You give it here. You write the program accordingly and you just vary the speed. So in almost all end, right? Now next, you have to maintain the pressure. Then you have to maintain the pressure. Then same, you measure the pressure. Accordingly, you increase or decrease the motor speed. So everywhere, motor speed is coming into picture. Correct? And there is induction motor and induction motor speed you are controlling by the VFD. Almost same setup we are having in the mechanical equipment. It takes huge building, like maybe from here to the first, second, like room of this block. Huge, it takes space. In that they are going for the two tank. One is underground tank, one is 200 ground tank. One here, and from there they take the water and throw it here. And they maintain this. They do more or less same thing. But they don't have temperature. They are maintaining actually speed and the pressure and the flow. But they are having the water because it's in mechanical. Huge setup. And pumps are having capacity of around like motors are having capacity of 15 HP. Huge motor and huge pump. Control strategy is the same, but application is different. Here we went for the air because it's in electrical department, that's why. Water we can't handle like in electrical department. That's why we gone for the air. But see, with the same strategy, just by changing the control strategy, you can have various applications. Correct? This gives some glimpse about VFD. Any doubt over here? Have you understood how we have done that? How closed loop was achieved? Correct? Okay. Already we have discussed, right? Already we know the SCADA screen and already we have worked upon it, so it's not a problem. But again, you understand that SCADA is connected to the PLC only by the two wires. It's only by the communication line it's connected. Just see, with communication line we are connecting SCADA to the PLC and we are switching on the SCADA, and with that actual three-phase motor is getting on. Right? So let us go for the VFD. You know this very easily because basically we have two, like we have basically rotational. Whenever you need a rotational speed, you need to have a basically you have two type of speed. One is fixed speed, second is a variable speed. So for a fixed speed application, you will go for the device which can work with the fixed speed, but for variable speed, you need to go for some device which can produce variable speed. And see now if you see in the market, no, the available motors are very less, or type of motors are very less. Is it true or false? See, earlier we have DC motors and class of DC motor like DC series, parallel, compound, all the thing. But it has a lot of issues with the maintenance. Why a lot of issues? Because Indian Railways earlier used the DC motors only for the engines. Now also some old engines are having DC motors, but now it's replaced by the induction motor. Even the new trains like in Vande Bharat, you don't find DC motors; it's induction motor only. Even in the like metros, we have induction motors only. So why they replace DC motors and why DC motors are
Brush and commutator.
Yeah, main issue is the maintenance, right? Because bursts are there, so every time it will deposit the carbon on the computer segments, every time they need to clean it. Like technician has to open it, they need to clean it. That's why, if you observed earlier, the trains are not working for one day in the week. The break was there because only for cleaning that computer segment. Mandated. It won't work for that. So now that problem is overcome by going for the induction motors. And we are having so many applications for the variable speed. And the main product the induction motor already has said. So these are the applications where you need a variable speed. See, so many applications. These are just few examples. We need some conveyor belt where we need a variable speed. We need some pump where we need a crusher. We need, you know the meaning of crusher, right? Which will crush the say big stone to the small stone or something. So if heavy stone, then you need to decrease the speed like anything. If you go with more speed, then that crusher will break. So you need to go for very low speed. Then agitator, tank door, hand door, machine door, and undermining, and so many things where you need variable speed. And to achieve the variable speed with the induction motor, you can go for the VFD, and there are the variable various types of the VFD. See, you will surprise many times VFD is also called inverter. If you go to the local industries, no, they know. Do you know we have inverter programming, inverter configuration? They ask in that. Sometimes they also call it drive. Not AC drive, they call it drive. But its actual name or more technical name is variable voltage, variable frequency drive. It's not only variable voltage. It's not a variable frequency drive. This is the actual word. But now somebody, like it's also getting famous by VFD. All names are for same device. So whenever you use induction motor, and if you need variable speed, then you need to use the VFD. Other options are there, but they are not so you can say physical. This is the most common option, and everybody will go with this option. So fine. Okay. So you might be knowing it, but I'll just highlight something. The main use of VFD is the starting. So what is the meaning of starting?
Smooth starting.
You have smooth start, right? See, like suppose if, just to understand the feel of proper starting, you travel in the old type of lift which has shutter or something. Just close the shutter, you press button, whoop, it will just makes a sound and it will just start. And maybe you travel in some lift where just press the 5, slowly it will start. You will experience in the both the lift operation. In that lift it was like this. In this lift it's like this. It has very smooth start. Correct? So this starting also sometimes we need a smooth starting. Right? Because see, nowadays we are having some train which reach the speed 130 km/h. And if it's starting of that, it's very smooth. You won't feel jerk in something. It's very smoothly achieved with 130, very quickly also. And you can see the speed also 130 km/h, very smoothly achieved. So for starting, we want actually control start, proper start. That's why we need to use VFD. And also sometimes maximum time we have a delta connected induction motor. And delta connected induction motor, if you go for it, then above 5 HP induction motor, you need to use a starter. Why? It draw 5 to 7 times full load current. So just to reduce that current by 1/3 time, you use the starter. Correct? So if you use the VFD, then there is no need to use a starter. You can use the motor directly. You can start the motor directly without using starter. If it's below 5 HP, you can use the motor directly with the DOL direct online. But if it's above 5 HP, you use starter. But if you use the VFD, then starter is not required. You can have a smooth start. That's why people will prefer VFD. Second is speed change. See, if you use the VFD, then you can change the speed like anything. Sometimes you run in the 10 RPM, 20 RPM, 30 RPM, 40 RPM, whatever speed you want, you can run the induction motor. And that too with a full torque. See, somebody can run the motor with less speed, but you need a full torque. No. So that is possible with this. And I think you might be knowing this curve. And this is very, very important curve. power line. This is frequency. See, so why we prefer VFD? The one of the reason is this. This is a power line. If you run at the rated speed, power will be the maximum power that VFD will consume. But if you run at the lesser speed, amount of power taken will be accordingly. That's why in the application that you consider, no, when to reduce the flow by 50%, actually you reduce the speed by 50%. So when we reduce the flow speed by 50%, actually we are saving the power. Because so ultimately, same application you consider, we can operate the speed, you can get a desired flow by operating the head operated valve also. But we see that if you do it, then it's a clear wastage of power. If you do with the VFD, then benefit is we'll run the flow at this less speed and we'll achieve the same task. So when you do it, it's a saving of power. This is a power line. So if you run at lesser speed, that's why it saves the power. That's why you have so many advertisement with the inverter based AC. Because if you inverter base some device, then if you work with the lesser range, then it will save the power. If you run at the maximum range, then it's not going to save the power. Lesser range only, it's going to save the power. Correct? Okay. Is it clear? Correct? So this is fine, power. So obviously it's very clear that if you use a VFD, then with lesser frequency, you will save the power. But what about torque? This is torque. So the torque will remain same in the entire range with the VFD. So even though motor runs at a lesser speed, it's not possible to hold the shaft of it because torque is same. Water torque we are getting at the full speed, same torque we are getting at less speed also. That's the benefit of the VFD. We have tried with our lab, like we have connected VFD with induction motor, we try to hold the shaft, but it's not so easy. It gives the full torque. Right? So this is the torque line. This is the power line. Clear? Okay. So next is stopping. So what do you mean by stopping? Stopping means
removing the power.
see now this is the main problem. Suppose I have some motor. If I remove the power, then it will go for the inner based on inertia, it will stop. So in many applications, it will not solve the purpose. Like suppose you have some winder where suppose the cutting is happening and as soon as stop, it should stop immediately. Then it's not going to. Otherwise, it will be different. Inertia will be there. Like for example, suppose you have three motors which is working in synchronism. One is 5 HP, one is 1 HP, second is 10 HP. Then all power you went stop at the same time. Then all will go with different inertia. Suppose you're working with some cloth or some material and all will go with different inertia, then all will stop at different times. That's not preferred. So your meaning of stopping means it's a controlled stop. Controlled stop is very well stop, after some time it will stop. Like it's like this. Suppose 10 seconds. So once you press the stop, in 10 seconds it will stop. And all will stop at the same time. It will overcome the inertia. You understand that? It will overcome the inertia. So just for a more curiosity, just for the fun, what we have done now in this, we are running our motor with the practical we have did. We have put that 10 second to 0.1 second. And motor is not connected with the load, and you have press the stop. So as soon as you press the stop, motor will stop. Like inertia, it will overcome the inertia to stop rotating. I hope this is clear. Otherwise, suppose if there is no fan in this class, but if you turn on the fan and if you switch off, then once you switch off, power will stop, but it will stop as per its inertia. Correct? But we don't want that. We want that it should stop as per the requirement. In many applications, in textile, that is needed like anything, because whenever all motor stop when cloth over, then it should stop. Suppose some embroidery is happening, then all should stop at the same time. So that should happen. So here with VFD we can have a controlled stopping. So we did it with 0.1 second because load was not connected. If the load is there, then you can't do it. It depends on the mechanical load, whatever you connect. But it's possible. It will overcome the inertia, it will stop. So So next is reversal. If you do forward reverse, you know, if you do forward as a induction motor, you have to do what? How you can do the forward reverse? You need to change the phase sequence. But now in automation, who will go and who will change the phase sequence? Like you delegate the work to the machine. So in VFD views, it will change internally only. It will just do the firing of, you know, the construction of it. You know, it will just say the firing angle. It will fire other IGBT. It will change the phase sequence and water box it direction. It's very easy in this. And last is main is energy saving. Whenever you use the VFD, it will be energy saving if you work with the lesser than rated speed. You always have. That's why people prefer the VFD or not. I know that, yeah? Okay. Clear? Huh? Right? So it will be always like this. Correct? So now let us see one thing. It's very, very interesting, and then afterwards, a few weeks, we'll stop. This diagram I want to tell you. Many are not knowing about it. This is actually a practical schematic diagram of one of the famous companies VFD. So actually there are two parts in this. One is control part. One is the power part. So this is actually a special type of VFD in which supply you give a single phase and output is three phase. Output is three phase. But definitely output is only 220 volt three phase. It cannot make 440 volt. But three phase supply we are getting here, and motor will work with the three phase, no problem. So this is your power circuit of the VFD. This is a control circuit of the VFD. So what we have in power circuit, already you know that. Right? First you have a converter. Like you have a AC available. Ultimately you have to change two things. You want to change. What you want to do? You want to change the frequency. You want to change the voltage. So very first thing that you do is will make AC to DC. If it is three phase, then we will go for three phase supply, and here we will go for three phase converter, which convert AC to DC. So you have DC link voltage, you know. Again, from the DC we will make our AC by using inverter. So what do you know? Inverter is one of the component in the drive. So we can use inverter. And the inverter only will change frequency and will also change the voltage. How will you change the voltage? By doing some PWM technique, SPWM or anything you can do, space vector, whatever you do, and with that you will change the voltage and frequency also you are changing. Frequency changing by changing the duty cycle, right? Duty cycle will change frequency. It change the voltage. How will you change the voltage? By changing duty cycle, right? How will you change the frequency? Yeah, by changing the cycle time, right? You can do that. So that will be fired by what? It will be by microcontroller. Again, see, here using microcontroller because VFD is made in bulk. It's made in mass. Suppose it's VFD of some companies, a Siemens company, then Siemens will make thousands of VFD per annum. So this controller only will fire this, right? And along with this, the main thing is here. You have so many digital input. So digital inputs are for what purpose? To start the motor, to stop the motor. You can start the stop motor and stop the motor from where? From where? From manual you can do. Second is remote you also can do. You can connect that. You can connect this input, start and stop input of the VFD to the PLC output, and PLC you connect to the PLC connect to the SCADA and SCADA motor remotely. So remotely also you can make the motor on. Maybe you might have seen some video where locomotive pilot is controlling the engine from sitting outside. It's there in some abroad if you go in some part of the Western country. Whenever they park the locomotive, the driver is outside and it is controlled with the remote and locomotive is going and it's just parked in local proper position. There are not so many person like the way we are having. So they just control manually. One person is controlling all the locomotives, they park all locomotives at a proper path. by sitting outside, not inside. It's possible, so here also you can do. So to give start stop command PLC, again you understand PLC output will be input to this and it will operate it. Similarly, to give the frequency, we have a analog output of the PLC and analog input of the VFD. Analog input of the VFD. So when you give 0 to 10 volt output from the PLC, here you have written, right? So that will act as input to the VFD. So accordingly you can change the frequency in the VFD. So see, everywhere it all depends on the control. Power is same. That's why monopoly will be always maybe say maximum drive in the control, not in the power. Power means 3 phase means you do 3 phase, nothing. Not much thing. Correct? So that's why digital input and analog input of the VFDs are used a lot. Correct? Sometimes we also have the digital output and the analog output of the VFD. With the using the digital output of the VFD, you can start other motors. Suppose you want to operate 2 or 3 motors in synchronism. Okay, when this motor reaches 25 hours, you start second motor then. Based on this, you will command us third motor will start. So a lot of things you can do. Very easily. Right? So this will be there more or less in all VFDs. And main is this one, control. How you are controlling it. Correct? So this whatever I discussed, it's written here. So also it has, see, and here the main thing is the protection. Whenever you operate any induction motor in the VFD, it will provide proper protection. It will give for the over voltage, under water protection, over temperature protection, ground fault protection, source current protection, AICTE means it's a thermal protection. It is against positive temperature coefficient for water protection. Means all type of protection will be given by the VFD. So there will be no issue with the motor at all. Because when you operate, because give it to student, they will do whatever they want to do, they can do. Nothing will happen to the VFD, nothing will happen to the motor. Because it will be protected in very good manner. If you give proper supply to the VFD, nothing will happen. It will operate nicely. But you can control it in the way you want. Correct? So actually, whenever you want to start any VFD, you will configure it. That is called actually parameter setting. And in this VFD, this is actually Siemens MicroMaster FM440. In this VFD, you have to do the quick commissioning. And quick commissioning you can do only by configuring some parameter. You know the meaning of configuration, the meaning of programming. So what is the difference? What is the meaning of configuration? What is the meaning of programming? In PLC, we need to do the programming. In SCADA, sometimes we need to do configuration. In HMI, sometimes we need to do configuration. In VFD, we need to do configuration. So what is the meaning of configuration? What is the meaning of programming?
Programming means we have to do the logical arithmetic operation, and SCADA and PLC doing the VFD doing the scaling like.
Okay, almost correct. Actually, in programming you have freedom to do so many things. Like you can do arithmetic operation, logical operation, or whatever you write, you can write. Configuration is your fixed options. Option 1, 2, 3, 4. Out of that, you will select one. That's the meaning of configuration. So in VFD, there will be each parameter has the configuration option 1, option 2, option 3. Likewise, there will be n number of options will be there. You will select one option at a time. That is the meaning of configuration. And it's very, very simple. We have the manual, just refer it, write it, like these parameters are there. For example, anyone can understand P1001 parameter is whether it's European or America. It just define the frequency. If it's a European, then 50 Hz, American, then 60 Hz. You select 50 Hz over. Then application 205 parameter number. Application is constant speed, variable speed, constant torque, that you select accordingly. Then mainly is this motor power rating, motor current rating, motor voltage rating. So whatever is the motor rating that you see from the nameplate, you enter that, it will be over. Correct? Then you can see 700 selection of command source. So from where you want to start your motor? You have to start the motor from the input output, or you have to start from the VOP or the panel which is given in the panel. Normally we always go for the terminal. We always give the starter motor from the input because it will be connected from the PLC maximum time. So you on the something on SCADA, it will give command of PLC, PLC will operate the VFD. So it will be through input. Then what is the medium frequency, what is the maximum frequency? And this is also good. Suppose you want that my motor should never exceed say 25 hours, then you can fix that frequency. So it will never go beyond that. Okay, you can set in minimum speed and maximum speed, and these two are very good. 11, 20, 11, 21. That is ramp up time. Just this time. So you start the motor after say 10 seconds. For example, it should reach to maximum speed. No, sometime you might have somebody may be traveling the say patient lift in the some hospital somewhere. In the patient lift, it's very smooth. It won't have any jerk because they give the more acceleration time. This acceleration time is more. So the acceleration time is more. So you can set that time by using this parameter 11:20. And next is ramp down time. This time. This is ramp down time. Then down, you can select this ramp down time also by selecting this. So whatever time you want, you can give. Accordingly, you can achieve your application. Correct? So once you configure this, you can achieve your application very nicely. And configuration is very easy. But even although it's very easy, but even many students or many people are not knowing the configuration of it. And in businesses, in day-to-day life, they need it. That's the irony of it. Because whenever you go for induction motor, it's never controlled the way we sometimes do in the lab. It's always controlled by the VFD motors. We go for relays or any application, it's controlled by the VFD software. Correct. So if anybody want to know this in detail, I can explain them, and if they come to Server Institute, I'll do the demo also, and they can also operate with it. I'll do the setup and they'll do operating with it. Correct. So here I am just giving some glimpse of something like that you will do. Once you configure it, then start working with the VFD. Very nicely. Very nicely you will operate with it. Correct. Correct. So with this I think we'll conclude now. And one thing is left is PLC programming. Again, if time permits, sometime we'll have some session of PLC programming, but it will take some time, maybe 4-5 hours it takes to at least write 2 to 3 small programs. And once you write it, it will be very easy. It will be very easy. Even those who do not like the control programming, they can like the PLC programming. It's very easy. And maximum tasks people nowadays doing in industries to PLC. Although they are doing, but they don't know programming. They rely on some other persons or for the program. But if you know programming, it will be operated. Correct? So already this is the conclusion. Already you control the temperature, like you control the flow by having various conditions. Also you vary the temperature also to maintain the flow. Correct? So if you have doubt, you can ask. Actually, I also planned for the PLC, but I thought time will be more, but now time is less, so we can't cover PLC. It's there below that. And any questions, any doubt, any clarifications?
रिले मार्शलिंग ऐसा वर्ड आता है मार्शलिंग जैसे ये प्रोटेक्शन में जो रिले आती है उसमें ये कॉन्फ़िगरेशन जो करते हैं ना उसको मार्शलिंग बोलते हैं
हाँ in control relay it's something like that. That's why I see very clearly, because see, when I say relay, the electrical engineers they always think about production relay. That's why purposefully I say control relay. And then also I also say it's not used for production. So they are actually having some configuration, but more or less their also objective is more or less same only. But here the objective of this is basically it acts as actuator, because with less supply you have to control huge power. And that is there everywhere, you believe or don't believe. Like it's there everywhere. Because whenever somebody will work with the actual thing or actual project, they need to convert huge power into small power. And that they can do with the actuator. So here it's a configuration you can use directly. Just like actuator, you should not have any CPU or something. Just connect it to give the output. And both are separate supply. Both are not believe then interest will develop more. More interest will develop. Correct. And if you suggest for your students, and definitely it's very useful. At least now a lot of scarcity in the industries for the job, and it will be very useful. Now also it's useful, in future also it will be very useful, because without this nothing is going to happen. See, I just give you a very good quote said by one of the directors of one very famous company. What they said it, now all are going to software industries. So he just quote one example. I don't want to give the name of the person, but what he said, you see, Zomato can deliver the food only when somebody makes the food. You understand the meaning of it? Software can work only when other industries are there. If it's not there, it's not going to work. Right? Because now the way we are feeling now, the pressure in the coal industries, that's a huge pressure, because people are not there. And all people are going in some other segment or other thing. We need people in all segment actually, in nutshell. But it's not there, that's the reality now. You also know, we also know. Correct? So when you go for core industries, this is one of the very popular topic, which is always, it will be useful. So we'll stop with this. So thank you very much.